Hi, welcome back. Today we are going to show the system equations and we will do it by two methods. Now let's get started. First of all, we rewrite the system equation. We have the x power of 4 equal to y and y power of 4 equal to x. And think about the method so that the first method we can apply this to the very direct method is we just replace x in, we let it 1 and this is the equation 2. We just replace x in the equation 2 into the x of the equation 1. Then we have the from 2 we have x equal to y power of 4. So then it means we can replace the x in the 1 and we have y power of 4. It means x power of 4 equal to y, and we will have the y power of 16 equal to y, and from this we can prove that by y and y power of 15 minus 1 is equal to 0, and there two values y is equal to 0 and y equal to 1. So then replace it to 2, so we will have x will be equal to 0 and and x is equal to 1. Then finally we have two pair of variables if this system equation is 0 and 0 and 1 and 1. So that is the first method. This is a very direct approach. Now we move to the second method. It's a method 2. So look at the equation. Rewrite it again. First of all, we put the condition for x and y. We have x power of 4, so it means x power of 4 on greater equal than 0, and similarly for the y power of 4, it's also greater equal to 0. It means x and y have to be equal or greater than 0 as well, because it's equal to the left side. So that's the first thing we can see from the system equation. Now let's put the first equation minus to the two equation. So then we have x power of 4 minus y power of 4 equal to y minus x. And we prove that x power of 4 minus y power of 4 equal to x squared minus y squared multiplied by x squared plus y squared equal y minus x. And similarly we have x squared minus y squared equal to x minus y multiplied by x plus y multiply x squared plus y squared. Then we have the similar thing on both sides equation is x minus y. Then we prove that minus y x minus plus 1, okay, equal to 0. Then we will have x have to be equal to y, or x plus y, x squared plus y squared must plus 1 equal to 0. The second one cannot equal to 0 because we have the condition, we have already ruled that this one. So this has to be greater than 0. This also greater than 0. So the product of both expressions have to be greater than 0 and plus 1. It means it has to be greater than 1, greater than 0. So this impossible solution. So we move to the first case, that is x equal to y. Then we replace to one of the equation in the system equation. We have x power 4 equal to x, and we have x equal 0 or x equal 1, and we have y equal to 0 or y equal to 1. And finally, we have the same result as the first method. We have 0 and 0 is the first pair, and the second pair is 1 and 1. So, both method we have the same result. That's correct. So why I introduce you two methods to show this kind of system equation? Because for the method 1, some kind of the system equation is easy to replace x from the second equation into the first equation, and you can find x by the equation has only x value. That's a very direct solution. But in another case, we cannot see the value of x and cannot replace from the 2 to the first equation. So we have to apply the second method by minus or plus the first equation to the second equation and group that by the same factor. Then we will have the product of the least factor. Then we check the factor equal to 1 to 0 1 by 1. That's the second method approaching. So I think it will help you in your math problem and your examination. Thanks for watching. See you later. Bye.